Previously, when we talked about the types of roots that we had, if we got a negative for the discriminant, we just said that the roots were not real or they were imaginary. Now we're just going to take it one step further and actually solve it using the imaginary number I. So basically, take the first equation that you're given there, x squared plus 4x plus 5, and solve it using the quadratic formula. So the quadratic formula is x equals the opposite of b plus or minus b squared minus 4 times a times c, all over 2a. So 16 minus 20 is negative 4. So the square root of negative 4 is 2i. So we have negative 4 plus or minus 2i over 2. We're going to write this in simplest a plus bi form. You'll see up above. We have a plus bi form. So this is the standard form that we write imaginary numbers. So we're going to write negative 4 over 2 plus or minus 2i over 2, and then we're going to simplify it and get negative 2 plus or minus I. So the only thing that we're doing different now that we didn't do before is we're taking a negative under the square root and we're finishing simplifying it using imaginary numbers. So let's look at the second one. Okay, for the second one, we have x squared plus 12 equals 6x. So the first thing we need to do is write it in our standard form of ax squared plus bx plus c. So we subtract the 6x. Same idea, do the quadratic formula, x equals opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. So we have 36 minus 48. So 36 minus 48 is negative 12. I'm going to go back up to the top for space. So negative 12. Well, the negative is the I. 12 breaks down to the square root of 4 and 3, or 2 square root 3. So we get 6 plus or minus 2i square root 3 all over 2. Again, to write in simplest a plus bi form, we must separate the two fractions, or separate this into two fractions, and finish simplifying. So 6 over 2 is 3, plus or minus, the 2's cancel, I square root of 3. Okay? So the only thing here, like I said before, is just that we're simplifying the negative under the radical. And that basically is section 5.6. So go to the next page, and we're going to talk about the sum and the product of the roots. So you have 2x squared minus 5x plus 3 equals 0. So reverse FOIL this. Well, we know we have 2x and x. We know we have 3 and 1, so we have to think about order. If I get a negative 6, oh, that's not going to work. They both have to be negative to get a positive 3 and a negative 5. So if we do negative 3 and negative 1, we get negative 3 on the insides and negative 2 on the outsides, which adds up to negative 5. So if we set that equal to 0, set each part equal to 0, add the 3, divide by 2, we get 3 halves. For the other one, we get x minus 1 equals 0, so x equals 1. So the answers that we got: 1 and 3 halves are the roots, or the zeros, or the solution to the quadratic. Let's look at if we add these roots together. If we take 3 halves plus 1, so that's 1½ plus 1, 2½, and we would write that as a fraction, 5 halves. So that's the sum. What about the product? If we have 3 halves times 1, we just get 3 halves, the product. Look at the numbers that you got for the sum and the product, and look at the original. We have a 5 on top. Notice that in the original we have a negative 5 as our b term. We have 2 on bottom of the sum. Notice our a term is 2. For the product, the numerator is 3. Notice our c is 3, and again 2 on bottom, and our a is 2. So what conclusions can we come up with? The sum is equal to the opposite of the b term divided by a, and the product is equal to the c term divided by a. You need to memorize these. Now, you can always find the roots and add them up or multiply them to actually find the answers, but you're going to see in a little while there's a couple of examples where we actually need to know these formulas to solve the problem. Okay, so the first example you have is x squared plus 5x minus 4 equals 0. So find the sum and the product. Like we said, the sum is opposite of b over a. So the opposite of b is negative 5, a is 1, so the sum is negative 5. Product. Product is c over a. c is negative 4, a is 1, so the product is negative 4. Try the second one. (3x squared plus 3x plus 5 equals 0. So what's the sum and what's the product? The sum is opposite of b over a, so negative 3 over 3, which is negative 1. The product is c over a, which is 5 over 3. Okay, so once you have those two memorized, pretty simple to do. Next problem. Now we're going to go backwards. We found the solutions. Right, now we're going to go from here and we're going to go backwards, backwards, back to the original. So if 1 was my solution or my root or my 0, x minus 1 is a factor. If I have x minus 1 times any other factors, I can FOIL them and come to the original. So the same thing here. 3 and 5 are my roots, are my solutions. X equals 3, x equals 5. So we can set each of those equal to 0. So x minus 3 equals 0, x minus 5 equals 0. FOIL it, x squared minus 5x minus 3x, 3 times 5, or negative 3 times negative 5. So there is my quadratic whose roots are 3 and 5. The second one gives you 2i. What you have to remember is that imaginary roots come in conjugate pairs. So even though I only gave you 2i, you should know that negative 2i is also a root. We're still going to do the same procedure. We still have our answers. 2i and negative 2i go backwards. So if my root is negative 2i, then my factor is x minus 2i, opposite sign. If my other root is negative 2i, then my factor is x plus 2i, again, opposite signs. FOIL it out. X squared minus 2xi, that should be plus, minus 2xi minus 4i squared equals 0. Because they're conjugate pairs, those two terms cancel each other out. I squared is negative 1. So we have x squared negative 4 times negative 1 plus 4 equals 0. So there's your quadratic, x squared plus 4, that has the roots of 2i and negative 2i. Next page. So here's where you can use the sum and the product of the roots to solve an equation such as this. So we're given x squared minus 3x plus c equals 0, and one of the roots is 5. So that means we have x minus 5, but we don't know the other one. Well, if x minus 5 is one solution, we know that we need negative 3 as our b term. So what factor would we have here to make the b come out to be 3? Well, we would get negative 5, so negative 5 plus 2 would give us negative 3. We'd get negative 5x, we'd get positive 2x. That gives us our negative 3. So the question is, what is the other root? The other root then would be negative 2. Remember that signs change. Next example. Find two numbers whose sum is 4 and whose product is 5. Use the quadratic equation to find the roots. Okay, so the sum of two numbers. So we have root 1 plus root 2 equals 4, and root 1 times root 2 is going to equal 5. So we can go back to the fact that the sum of the roots is opposite of b over a, and the product of the roots is c over a. So our quadratic equation would be x squared, opposite of b. A is just 1, right, because 4 is over 1, 5 is over 1, so a is 1. B is the opposite of 4, so negative 4x, and c is 5. So there's your quadratic. And it said to find the roots, so the actual roots we can get by reverse foiling this quadratic. And it doesn't reverse foil, so you would use the quadratic formula and find the roots. Okay, next page, last page. Okay, so here's 3 more examples. I want you to pause the video. The last one is 2 plus or minus 3, so 2 plus the square root of 3, 2 minus the square root of 3 are the two roots. So try each of these and then come back to the video and see if you got the correct answers. Alright, for the first one, simply using the formula, sum is the opposite of b over a, product is c over a. Plug it in. You get 3/2 for the sum and -1 for the product. Second one, one of the roots is -3, so x plus 3 is one of the factors. So basically, what other factor do we need, or what other number do we need to get -8 as the b term? So if we have a positive 3, we need a -11, because a -11 plus 3 gives us -8. So x minus 11 is the other factor, and our root is then 11. Sometimes they'll also ask you what c is, so then you would have to say c is -33. The last one, not difficult, but takes a little time to get used to. Now I'm going to give you the roots, and you kind of work backwards. So if I give you the roots of 2 plus the square root of 3 and 2 minus the square root of 3, you can add those together and tell me what the sum of those roots are. The sum of those two numbers is 4. You can also tell me what the product is. FOIL them out. Remember, because they're conjugate pairs, that the two middle numbers cancel each other out. So you get 4 minus 3, which equals 1. Then remember that 4 is the opposite of b over a, so obviously a is 1. And the product is c over a, and again a is 1. So we have our quadratic a, which is 1, x squared, opposite of b, so -4x, plus c, which is 1. So that's it for now. See you next time.